So I'm going to go through a few sample problems from 3.1. Starting with this question, it says for the following equation, determine the values of the missing entries. Reduce all fractions to lowest terms. So essentially we're filling in a table of values where they give us a value for either x or y. So basically we have, this is an example, basically have 5 problems in one. So we look at this first problem, they give us a value for y, so we're going to substitute 0 for the y variable in the original equation, and we're going to solve for x. So we've substituted 0 for y in that equation right there. So we've got a quadratic trinomial here, so you should recognize this is something that can be factored. And if you want to use the a times c method, which we've discussed, where you take the first number, the a value, and multiply it by the last number, the c value, even though remembering when that lead number is 1, it doesn't really change anything. We're looking for two numbers that multiply together to give us 4 and add together to give us -4. So of course those two numbers are -2 and -2. -2 times -2 is +4. And -2 plus -2 is -4. So those are the factors. So you get repeated solutions. In this case, both of those factors are going to give you a solution of 2 for x. Okay, so I'm going to clean this up just a little bit. And I'm going to jump ahead, and I'm going to do this middle column. This time they give us a y value of 1. So they want us to find what is x when y is 1. So I'm going to take that same equation, except this time I've substituted 1 for y. It's still a quadratic trinomial, but it's not equal to 0. And remember, to be able to use that zero product property, we must set it equal to 0 first. So I'm going to subtract 0 from both sides. And I'm going to pause for a second, or I encourage you to pause the video for a second and see if you can factor this to get the solutions to this problem. Or you could use quadratic formula. You should get nice, neat whole numbers. I'll pause. In about 5 seconds, I'll go over the answer. Okay, so we are looking for two numbers that multiply together to give you 3. There's really not any combinations other than 3 and 1. But they also have to add together to give you a -4. So that tells us they both have to be negative, which means the solutions are x equals 3 and x equals +1. This note says each column of the table represents an ordered pair. If multiple solutions exist, you only need to identify one. So when y is 1, I'm just going to say x is 3. But I could have also said x is 1. Okay, and finally, I'll do one where they give us a value for x. So they say, okay, x equals 5. What is y? So here we are just substituting 5 everywhere we see an x. So this is a lot more straightforward. Y is just going to equal whatever 5 squared minus 4 times 5 plus 4 ends up being. 5 squared is 25. 4 times 5 is 20. Do the math there. I think that ends up being 9 for y. Next example, similar process. I would encourage you to try a few of these on your own. The ones I'm going to do in about 10 seconds are these three that I've circled. So I encourage you to pause and try this on your own, and I'll start going over it in a couple of seconds. So I've already set up the first example. I've substituted the square root of 7 for y. We want to solve for x. And we should recognize that taking the square root of a number is the inverse operation of squaring a number. Or another way to think about this is when you square a number, you multiply it by itself, right? So the square root of 7 squared is the square root of 7 times itself. 7 times 7 is 49, and the square root of 49 is 7. So again, two ways to get that answer. You could also have known just when you square a square root, you get the number underneath that radical. The next example, they give us a value for x. X is 25, and we need to solve for y. So to solve for y, we're going to square root both sides. Remembering when you square root both sides, you open up a positive and negative answer. So plus or minus 5, you can put either one of those answers in there, and it will count it correct. This last one, remember, you are squaring the square root of 3, which we know what happens when you do that, but you're also squaring that negative 1. So again, multiple ways to think about this. The long way would be to actually multiply negative square root of 3 times the negative square root of 3, since that's what it means literally to square a number. Negative 1 times negative 1 is a positive 1. The square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. And that's your answer. So you have several examples like that. Refer to Hawks for further instruction, but the two examples I went through are definitely two of the harder examples you'll see. Okay, so moving on. So this next section, we are finding the perimeter of a triangle. And remember, perimeter of a triangle is the sum of lengths of all three sides. So we need to find the length of side 1, side 2, and side 3. And all they give us in this problem are coordinates of those vertices, which we don't necessarily have to graph. I went ahead and graphed them on kind of a makeshift graph. I would not really recommend doing it this way, and I'm not going to do it this way. There's a really horrible triangle I just drew there. That's what that's supposed to be. But basically, those are the three sides. We need to find the length of this side, and that side. So I tried to redraw that triangle, but I didn't do too much better. So the quickest way to find the lengths of all three sides is using the distance formula. We can use a distance formula to find the distance between any 2 points in the coordinate plane. And the distance formula is related to the Pythagorean theorem, which you probably know. If you're given two sides of a right triangle, you could use the Pythagorean theorem to find the third triangle. So here's what the distance formula looks like. It's the square root. And to find it, we find the distance from the two x coordinates, and then we square that value. And then we find the difference of the two y coordinates of the 2 points we're looking at, and we square that value. We take the sum of those two values and then take the square root. So let's see this in action. We'll have to do the distance formula essentially 3 times in this problem. So I'm first going to find the distance between these 2 points here. -4, 5, and -4, 3. Here are my x coordinates. Here are my y coordinates. It doesn't matter which one is x1, y1, and which one is x2, y2. You could invert that just as easily and get this right, but you do need to figure out what's x1, y1. You need to call something that. And then it's a simple matter of plugging it into that formula. Go ahead and do that. So here's the setup. Be really careful here. Similar to the quadratic formula, not incredibly difficult to understand because you're substituting into a formula, but easy to make small mistakes. Remember, we're finding the difference between the two x coordinates, and both x coordinates are already negative. So that's why we have a minus a negative 4 in here. So then we do the math. Negative 4 minus a negative 4 becomes 0 squared, plus 5 minus 3 is 2 squared. 0 squared plus 2 squared is 4, and the square root of 4 is 2. So that's an easy distance. We found the distance between those 2 points in the triangle to be 2. We need to do this 2 more times now. Now what I'm going to do is I'm going to find the distance between point number 2 and point number 3 using the exact same process. So here are my 2 points. And that's going to be my x1, my y1, my x2, my y2. And I'm going to substitute them into the distance formula. So negative 4 minus negative 1. And then my y's 3 minus, I wanted to do that in red, negative 4. And then just do the math. Negative 4 minus negative 1 is negative 3 squared. That's a horrible, horrible pin. Negative 3 squared plus 3 minus negative 4 is 7. Negative 3 squared is 9. 7 squared is 49. 9 plus 49 is 58. Then you have to think to yourself, okay, is that simplified? Is there a perfect square that goes into 58? Think about your perfect squares, like 4, 9, 16, 36. No, none of those perfect squares divide into 58 evenly. So the square root of 58 is as simplified as we can get. So this is the distance between those 2 points. Now find the distance one more time. I'm going to let you do this on your own. This time we are finding the distance from point 1 to point 3. Pause the video, and here in about 5 or 10 seconds, I will run through what I got for the distance between those last 2 points. There's my setup. And I am getting the square root of 90. Biggest perfect square that goes into 90 is 9, and it goes into 90 10 times. And so this simplifies to 3 radical 10. The way Hawks wants it, it doesn't want a decimal. So remember, to find the perimeter, that's what we're doing, the sum of lengths of all 3 sides. The actual perimeter of this triangle are the 3 sides added together in no particular order. doesn't want a decimal answer unless it's a nice, neat terminating decimal. But that's how you get it. That is your complete answer. And then real briefly, midpoint. I just want to talk about the midpoint formula. If you think about the word midpoint, it's like the average. And to find the average of two numbers, you add them together and divide by 2. That's exactly how you find the midpoint of 2 points in the coordinate plane. You add the x coordinates together, divide by 2, and you add the y coordinates together and divide by 2. So these are the 2 points we're looking at, 8, -2, and 6, 5. I always like to graph them just because I know my midpoint is going to be somewhere right around there. I can't eyeball it, so that's why I'm going to use the formula here to give me the actual coordinates. So there's my x1, y1. There's my x2, y2. And I'm going to substitute those into the formula. So I'm adding the x's together and dividing by 2. And I'm adding the y's together and dividing by 2. And there's another reason why we couldn't really just eyeball it, because the midpoint is at a decimal. And if you look at that red point, like just my horrible makeshift graph here, that looks like it's roughly at this point 7, 1.5. So the math kind of checks out with the picture.